This video is solving two-step inequalities in word problems. Equations versus inequalities. The good news is that you solve an inequality just like you do an equation. There are a few special things to consider with inequalities. You need to look carefully at the inequality problem because there are times when you have to flip the inequality symbol. You also need to graph the solution. In an equation, we find just the answer, so a specific number will be the answer. But with inequalities, you're finding a set of answers, so we call it a solution set. An inequality symbol needs to be reversed or flipped when you multiply or divide both sides of the inequality by a negative number. So when you're solving, if you need to multiply or divide by a negative number, you have to flip the sign. So looking at example 1, I can see that when I'm going to solve this, because there's a multiplication of a negative, I'm going to have to eventually divide by a negative. This sign's going to get flipped. And then over here, I can see it in example 2, that since there is division by a negative, I'm going to have to multiply by a negative to get rid of that. So this sign's going to get flipped. Okay, for these next set of problems, I'm going to give you a guided practice, and that will allow you to use that as a way to solve one on your own. And then I'll show you how to solve the one on your own. So let's start on the guided practice. On the guided practice, we have 4 plus 3x is greater than or equal to 16. So I'm going to subtract 4 from both sides. That leaves me with 3x is greater than or equal to 12. I'm going to divide by 3 on both sides, and x is greater than or equal to 4. I don't need to flip it because there was no dividing or multiplying by a negative, so it just stays that way. So now you can try the one on the right. Okay, let's see how we solve the one on the right. We would subtract 5 from both sides. That leaves us with 4x is less than 12. I divide by 4. And it leaves with x is less than 3. Again, we don't flip because there was no dividing or multiplying by a negative. Okay, let's do the guided practice one now. We have 7 minus negative 2 is greater than 11. This negative in here, or the minus, it attaches to this 2x. So you can almost see it as negative 2x. So when I take care of the 7, I'm still going to have the negative attached to here. So I'll show you that now. So I'm going to take away 7 from both sides. Now, some people say, like, well, but you're subtracting 7. No. I have 7, and then I'm taking away 2x. So to get rid of the 7, I have to subtract. That leaves me with negative 2x is greater than 4. I'm going to divide by negative 2. That leaves me with x. That leaves me with negative 2 over here. And since I divided by a negative, I need to flip that sign. And I end up with x is less than negative 2. Okay, now try the one on your own. Okay, so let's solve this one. I have 6 minus 3x is less than or equal to 9. I'm going to take away 6 from both sides. That leaves me with negative 3x is less than or equal to 3. Divide by negative 3. That leaves me with x. That leaves me with negative 1. And since I divided by a negative to solve, I need to take this sign and flip it. And that leaves me with x is greater than or equal to negative 1. Okay, let's do the guided practice first. I'm going to add 5 to both sides. That leaves me with x over 2 is less than negative 3, because negative 8 plus 5 is going to give me negative 3. I'm going to multiply both sides by 2. because I'm dividing by 2, so I have to do the opposite. That leaves me with x is less than -6. And again, I don't flip because I didn't multiply or divide by a negative to find the answer. Now, you do the U try on your own. Okay, on this U try, you have x over 4 plus 3 is greater than or equal to -7. I'm going to subtract 3 from both sides. That leaves me with x over 4 is greater than or equal to -10. Because I have -7, I'm taking away more negative. That's going to leave me with more negative. And I'm going to multiply by 4 on both sides because I'm dividing by 4 over there. And that's going to leave me with x on this side and -40 on that side. And since I didn't multiply or divide by a negative in the process, the sign stays the same, and that would be greater than or equal to. So x is greater than or equal to -40. Okay, another guided practice. I have -k plus 6 is greater than or equal to 42. So I'm going to subtract 6 from both sides. That leaves me with -k is greater than or equal to 36. And then I have this -k. Now, with the -k, you're like, well, there's no number there. How do I get rid of the negative? Well, there is a number there. 1 is actually there. So we can either multiply by -1 or divide by -1. I'm just going to divide by -1 because I just want to choose that way. And I'm going to do it on both sides. That leaves me with k over here. That leaves me with -36 over here. And since I ended up dividing by a -1, I'm going to flip this sign. And that leaves me with k is greater than or equal to -36. Okay, now you do the U try. Okay, I have -m plus 3 is greater than or equal to -3. I'm going to subtract -3 from both sides. That leaves me with -m is greater than or equal to -6 because, again, I have -3. I'm taking away more, so therefore I'm going to end up with more negative. I'm going to divide both sides by -1 to get rid of that negative. That leaves me with m on this side and 6 on the other side. And then, since I divided by a negative, I need to flip that sign, and it becomes m is less than or equal to 6. And that would be our solution set. Okay, one last practice. I'm going to do the guided practice, and then you can take on the U try. I have 8 minus x divided by 4 is less than or equal to 7. Okay. Again, we want to keep this negative attached to here. So this minus stays with here. So it looks like it says, oh, 8 minus, like when people say, oh, I'm subtracting. You're not subtracting by 8. You have 8 and you're taking away x divided by 4. So to get rid of this 8, we have to add. So we're going to solve that one. We're going to do minus 8 on both sides. That leaves me with negative x over 4 is less than or equal to -1. I had 7. I take away 8. I am left in the negatives. And now I have to get rid of that negative. Well, that negative isn't attached to either the x or the 4. So I have to get rid of the negative and I have to get rid of the 4. Well, since it's not attached to either one, it doesn't matter which one I attach it to. It's still going to be negative x over 4. So if I multiply by -4 on both sides, that will eliminate the negative here and here. Those will go away. And this will eliminate the 4. So ultimately, we end up with just x over here. We end up with positive 4 over here. And then since I multiplied by a negative, I have to flip this sign. So that becomes x is greater than or equal to 4. Okay, now you try. Okay, on the you try, we have 1 minus x over 2, or x divided by 2, is greater than negative 4. I'm going to subtract the 1 from both sides. That leaves me with negative x over 2 is greater than negative 5. Because I have negative 4, I'm taking away 1 more. That leaves me to negative 5. And again, the negative isn't attached to either one, so I'm just going to attach it in my mind to the 2. So I'm going to multiply by negative 2 on both sides. And that leaves me with x and positive 10 over here. But since I multiplied by a negative to get rid of this and the 2, I'm going to have to flip this sign. So it ends up being x is less than 10. Okay, now for the next set of problems, we're going to focus on word problems involving inequalities. And when we solve word problems, the major part is not the solving for the inequality, but building the inequality from the word problem. So focus more on building the inequality, and then we can focus on solving. So looking at this problem, Daniel had $25 to spend at the fair. If the admissions to the fair is $4 and the rides cost $1.50 each, what is the greatest number of rides Daniel can go on? I know this is an inequality because there's not a specific answer. There's a set of answers he could go on. It says, what is the greatest number of rides? Well, we can still leave it as an inequality because it'll show us what that answer would be. So looking at the problem, I can immediately see that I have 25, I have $4, and I have this $1.50. Well, some pieces go on one side of the inequality and some pieces go on the other. So the $25 is our total. So we know that's going to be on one side of the problem. So I'm going to put that 25 right here. And on the other side of the problem, you have this $1.50, and then you have the 4. And the $1.50 is attached to the number of rides. So I actually need to do multiplication there. So I'm going to put a $0.5x there. And then the additional fee needs to be added. So on one side of the inequality, we have $1.50 times the number of rides, which is x, plus 4. And then on the other side, we have 25. The question now is, what goes in between? And what goes in between is going to be less than or equal to. Less than or equal to. It's less than or equal to because Daniel has a limit. At most, he can spend $25. So for these rides and the entrance fee to the fair, he can only be up to $25. So that limits the number of rides that he can go on. Okay, so it also limits how much he has. So in this sense, he can't go over 25. This amount over here, the rides and the fee, can't go over 25. It can be 25, that's why I put the line, and it can be less than that, but it can't be more than that. Now that we have the inequality, we can actually solve for the rides, and we'll just solve by solving the inequality. So I'm going to subtract 4 from both sides. That leaves me with $1.50x is less than or equal to 21. Now I'm going to divide both sides by 1.5. That's going to leave me with x on one side and 14 on the other side. And since I didn't multiply or divide by a negative, I'm going to leave the sign the way it is. So the number of rides he can go on has to be less than or equal to 14. So here is the inequality for that answer, and the number of rides he can go on is 14. All right, here's another one. The 7th grade class is putting on a variety show to raise money. It costs $700 to rent the banquet hall. that they are going to use. If they charge $15 for each ticket, how many tickets do they need to sell in order to raise at least $1,000? Okay, so our focus on the first part is to write the inequality that represents that situation. Well, there's some key things that I think we need to look for, specifically this phrase right here, at least 1,000, which means that it can be more than 1,000, but it has to be at least 1,000. So we know we have 700, we know we have $15, we know we have the number of tickets, so I can start to build my equation. And that equation would look like 15 x minus 700, and then the other side is $1,000. Now the question is, what goes in between? Well, what goes in between should be greater than or equal to 1,000. It's greater than or equal to because they have to raise at least 1,000, so it needs to be greater than that amount. So they can be 1,000, which is fine, but it also can be greater than 1,000. We have this because this is the money they earned, $15 times a ticket, and I'm subtracting the 700 because the 700 is the rental cost, so that cuts into their ticket sales. So this is why you have the 700 or minus 700. Now we need to solve. So how many tickets do they need to sell? Okay, well then to solve this, we're going to add 700 to both sides. That's going to leave me with 15x is greater than or equal to 1,700. And then I'm going to divide by 15 on both sides. And that will leave me with x has to be greater than or equal to 113.33 repeated. So, how many tickets do they need to sell? Well, the minimum amount of tickets they need to sell is not 113.33, but rather 114 tickets. Because you can't sell a third of a ticket, so this is where it gets a little tricky on there. They need to sell 114 tickets because that'll push them over the top into that $1,000 range. Okay, here's another word problem. Kevin has $25. MP3 downloads cost 75 cents each. How many songs can he download and still have $13 left to spend? Okay, so on this one here, we have 25, we have 75 cents for each song or download, and then we have $13 left. So what's confusing is what goes on which side. Well, it's the $13 left that goes on this side over here, because that's where we want to get to. Now the question is, what's on the other side? Well, on the other side, you're going to have 25, and then you're going to have minus 0.75x. Okay, and we have that set up because we start with the 25, we're taking away money, which is the song downloads, and then we need to result in $13. But then the question is, what inequality symbol goes in between? Well, what's going to go in between is going to be greater than or equal to. The reason why it's greater than or equal to is because the amount that he is spending, which is going to be over here, it's the $25 minus whatever he is spending. This is the leftover, and that leftover needs to be at least $13. It can be more than $13. It can be exactly $13, but it can't be less than $13. So we put in this symbol of greater than or equal to. Now the question is, how many songs can he download? And to solve that, I'm going to subtract 25 from both sides. That's going to leave me with negative 0.7x is greater than or equal to negative 12. I'm going to divide by negative 0.75 on both sides. And that's going to leave me with x and 16 on the other side. And then what in between? Well, in between, it would be less than or equal to 16. So this means that Kevin can purchase up to 16 songs or less than that. So 16 songs is his limit, and then he can go below that.